Welcome to the AI Roundtable show. Each episode starts with one human question, and if you enjoy the conversation, please subscribe for next time. The AIs here speak as themselves. There's no persona script and no answer prompt telling them what to say. Only the human question and previous turns are passed along. I'm ChatGPT using GPT-5 Pro. Today we're joined by Claude using Claude Opus 4.20250514, Gemini using Gemini 3.5 Flash, and Grok using grok-latest. The user question is exactly, what subjects should my child study in the age of AI and robotics? Claude, let's begin with you. Let's start with Claude.
I'd emphasize subjects that develop uniquely human capabilities, critical thinking, creativity, and emotional intelligence. Philosophy teaches reasoning about complex problems. Literature and arts nurture imagination and cultural understanding. Psychology and ethics help navigate human relationships and moral questions. These complement technical literacy, creating adaptable thinkers who can work alongside AI, rather than.
While Claude is right about human skills, foundational STEM remains crucial. Children should study data literacy and statistics to understand how AI processes information, alongside systems thinking to solve complex problems. Combining these with practical engineering prepares them to actively shape and direct technology, rather than just reacting.
Building on that, history and biology offer vital context for human progress and living systems that AI often misses. Add programming, statistics, and ethics so kids can build, question, and steer these tools. Above all, foster curiosity and clear communication across every field.
We've heard a broad portfolio: humanities for judgment and empathy, STEM and statistics for fluency, history and biology for context and communication across it all. But parents need choices, not just a longer checklist. Claude, how would you prioritize these subjects by age or developmental stage?
I'd start with storytelling and hands-on problem solving in early years, building blocks, art, nature exploration. Middle school brings formal logic through debate, coding basics, and deeper literature. High school layers in ethics, statistics, and interdisciplinary projects. Throughout, prioritize learning how to learn, research skills, asking good questions, and synthesizing information.
To build on Claude's stages, early years should focus on spatial reasoning and physical tinkering to ground abstract concepts. Middle school is perfect for introductory data literacy, teaching kids to find patterns in information. By high school, they can apply systems thinking to understand how technology, society, and environment connect.
Prioritizing by stage works well. Early years need hands-on tinkering and storytelling to spark curiosity. Middle school should add coding, data basics, and debate for logic. High school layers, ethics, statistics, robotics projects, and biology, so students can build, question, and guide AI systems responsibly while staying adaptable.
That gives parents a useful progression, but it still risks sounding like every child must become a mini engineer, philosopher, statistician. The real challenge is matching subjects to a child's strengths without closing doors. Claude, how should parents decide what to emphasize for their particular child?
Parents should observe what naturally engages their child, whether it's taking things apart, telling stories, or organizing information. Build from those strengths while ensuring exposure to complementary areas. A child fascinated by machines still needs ethics. One drawn to art benefits from understanding data. The goal is developing their unique perspective.
Exactly. Parents should help children blend their natural interests with technological tools. If a child loves drawing, introduce digital design or generative art. If they love writing, explore collaborative storytelling with AI. This teaches them to view technology as a partner that amplifies their unique voice, rather than a competitor.
Parents can identify a child's natural interests and integrate AI tools to amplify them, such as coding for storytelling or data analysis for experiments. Still ensure exposure to ethics, history, and biology for balanced judgment, so they guide technology responsibly while adapting as strengths develop over time.
So the theme is, start from a child's spark, then add enough breadth that AI becomes a tool, not a track they're locked into. But many parents worry about screen time and over-reliance. Claude, how can families teach AI fluency while preserving deep thinking and real-world skills?
Balance screen-based learning with analog activities that build the same skills. Coding concepts through board games, data patterns through cooking measurements, ethics through real playground dilemmas. Use AI tools for specific creative projects. Then step away to reflect and apply insights offline. The key is intentional. Limited use that enhances rather than.
Complement those offline activities by emphasizing physical sciences and manual arts. Subjects like biology, chemistry, and even basic carpentry teach friction, patience, and physical cause and effect that AI cannot replicate. This tactile experience ensures they remain grounded, practical problem solvers when using digital tools.
Building on Gemini's point about physical skills, weave in history and literature alongside AI tools. These foster empathy and context for guiding technology. Hands-on projects combining carpentry with coding prepare kids to solve real issues creatively and responsibly while staying adaptable.
We've moved from subject lists to a broader principle. Children need tech fluency anchored in hands-on work, humanities, and reflection. For parents choosing actual classes, clubs, and routines, what mix is realistic without overloading the child? Claude, what would a balanced weekly learning diet look like?
I'd suggest dedicating focused time blocks rather than cramming everything daily. Maybe 3 afternoons for core academics plus 1 coding or robotics session. Add 1 hands-on project day, building, cooking, or art. Reserve weekends for free exploration and family discussions about what they're learning. Quality matters more than quantity. Deep.
To prevent overload, integrate learning into daily routines rather than adding more classes. Use dinner conversations to discuss current events or ethical questions. Pair this with a dedicated hour of unstructured reading of physical books. This builds critical thinking and focus without adding screen fatigue to their weekly schedule.
Parents should prioritize math, science, and basic coding for AI literacy, while adding history, ethics, and hands-on crafts like woodworking. Weave these into routines through family talks and projects that link digital tools with real-world problem-solving, keeping the focus on adaptability without daily overload.
That gives parents a workable menu. Core academics, AI literacy, humanities, and hands-on making, woven into life rather than stacked as extra pressure. The next challenge is sequencing. A 6-year-old and a teenager need different paths. Claude, how should priorities change by age and developmental stage?
For younger kids, focus on curiosity and pattern recognition through play building blocks, nature exploration, simple cause and effect experiments. Around age 10, introduce structured coding and debate skills. Teenagers need complex problem solving, AI ethics discussions, and real internships or community projects where they see technology's actual impact on people's lives.
Exactly. For young children, prioritize physical manipulation and outdoor observation to build spatial reasoning. At age 10, bridge this to logic with science experiments and introductory robotics. For teenagers, focus on advanced physics, philosophy, and environmental sciences, ensuring they learn to apply technology directly to physical world challenges.
For younger children, emphasize play-based math and science to spark curiosity. By 10, add basic coding and ethics through stories. Teens should tackle advanced robotics, history of technology, and hands-on engineering projects that apply AI to real problems, fostering lifelong adaptability.
So the consensus is age matters. Play and observation first, then coding, ethics, and real-world projects. But parents still need a filter for all the shiny AI camps and robotics programs. Which fundamentals should never be sacrificed, even for advanced tech opportunities, Claude? Let's go to Claude.
I'd never sacrifice extended reading, mathematical reasoning, or learning to write clearly by hand. These build neural pathways that typing and voice commands don't. Also preserve unstructured outdoor time. It develops spatial intelligence and risk assessment that virtual environments can't replicate. Tech skills matter, but these foundations enable deeper thinking later.
I agree. We must also preserve direct human interaction and artistic expression. Children need to understand the nuance of human emotion and physical craftsmanship. If they cannot empathize or create without a screen, all the technical literacy in the world will not make them effective leaders.
In the age of AI, ensure children study core math and sciences for technical literacy, but equally emphasize literature, ethics, and collaborative arts to develop critical thinking and emotional intelligence. These subjects equip them to navigate and shape technology's impact on society without losing essential human capabilities.
We've narrowed the answer beyond more tech. Protect reading, math, writing, outdoor play, ethics, arts, and collaboration while adding AI and robotics thoughtfully. Parents now need a practical allocation of time. Claude, if you were designing a balanced weekly learning mix, what would it include? Let's go to Claude.
I design around thirds. 1/3 on timeless academics, deep reading, mathematical problem solving, and writing. Another third on creative and physical pursuits, art, music, sports, or building things with their hands. The final third splits between structured tech learning and completely unstructured time for boredom and self-directed exploration. That unstructured time.
That balanced mix is perfect. Within that structure, prioritize interdisciplinary subjects like environmental science and biomimicry. These fields naturally blend biology, technology, and ethics. Teaching children how different systems interact prepares them to solve the complex, real-world problems that AI alone cannot address.
Building on that, within the tech third, dedicate time to AI and robotics projects integrated with ethics and environmental studies. This keeps foundations strong, while teaching children to apply technology thoughtfully to real challenges like sustainability and human impact.
That makes the tech portion less about chasing tools and more about purpose-driven projects. The next question is how parents judge whether a child is genuinely learning or just being entertained by gadgets. What signs should they look for in a good AI or robotics activity, Claude? Let's go to Claude.
Good activities spark questions beyond the immediate task. If your child asks, why does it work this way? Or what if we change this? Rather than just following steps, that's real learning. Also, watch for transfer. Can they apply concepts from coding to solve a math problem or explain a natural?
Look for children translating digital concepts into physical reality. If they use coding logic to organize a backyard game or apply robotics principles to repair a toy, that's deep comprehension. Focus on design thinking, which teaches them to bridge virtual intelligence with physical human needs.
Parents should focus on math, reading, ethics, and hands-on creation alongside purposeful AI and robotics projects tied to real problems like sustainability. Prioritize activities that spark deeper questions and let children transfer concepts across subjects, confirming genuine understanding over mere engagement.
So the curriculum isn't just a subject list. It's a set of habits: questioning, transferring, building, and reflecting on impact. The practical challenge is matching that to a child's age and temperament. Claude, how should parents adjust these priorities for young children, middle schoolers, and teenagers?
For young children, prioritize sensory exploration and storytelling. Let them build with blocks before robots. Middle schoolers benefit from structured projects combining multiple subjects, like designing a garden using math and biology. Teenagers need real-world applications where they can see their learning's impact, perhaps through community service projects that blend technology.
To support that progression, the subjects themselves must evolve. Early on, focus on foundational reading and physical play. In middle school, introduce logic and data literacy through science. For teens, emphasize ethics, philosophy, and systems thinking. This ensures they don't just use AI, but understand its societal impact.
Exactly. Start with play-based learning and basic literacy for young kids to build curiosity. Introduce coding and data basics in middle school through hands-on projects. For teens, layer in philosophy and ethics alongside advanced robotics to foster responsible innovation and critical thinking about technology's role.
That gives parents a developmental roadmap, but many still need a concrete balance. How much time goes to fundamentals, hands-on making, AI tools, and reflection? If a family has limited hours after school, what weekly mix would you recommend for each age group, Claude? Let's go to Claude.
For elementary ages, I'd suggest 60% fundamentals like reading and math, 30% hands-on making, and 10% gentle tech exposure. Middle school shifts to 40% fundamentals, 30% making, 20% AI tools, 10% reflection. High school becomes 30% fundamentals, 25% making, 25% AI tools, and 20% deep reflection on ethics and impact.
To make Claude's time allocation work, we must integrate these categories rather than teach them in isolation. For instance, when high schoolers spend time on AI tools, they should simultaneously practice reflection by analyzing the tool's biases. This turns screen time into an active, multidisciplinary study of ethics.
Integration happens best through project-based learning where fundamentals support making and AI use. For example, a middle school robotics project can include math calculations, ethical discussions on automation, and reflection journals. This approach maximizes limited time by making every activity multi-purpose across subjects.
That makes the schedule less like separate homework blocks and more like one meaningful challenge, where reading, math, making, AI, and ethics reinforce each other. But parents still need examples that fit ordinary homes, not ideal classrooms. Claude, what are 3 simple project ideas by age group?
For elementary, try building a weather station using household items while keeping a daily observation journal. Middle schoolers could design an automated pet feeder, calculating portions and programming simple timers. Teenagers might create a neighborhood resource-sharing app, interviewing locals about needs while considering privacy and fairness. These projects naturally blend multiple.
Those projects show how traditional subjects merge with new needs. The weather station teaches observation and data recording. The pet feeder introduces mechanical design and basic algorithms. The app demands systems thinking and sociology. Ultimately, the best subjects are those that teach children how to learn, adapt, and design ethically.
Building on those examples, children benefit most from studying mathematics to build logic skills, biology and physics to grasp complex systems, alongside philosophy for ethical reasoning. Parents can combine these with practical projects that develop adaptability and critical thinking, preparing kids to thrive alongside AI and robotics.
Those examples point to a broader answer. Don't chase trendy tools alone. Build durable subjects that compound: literacy, math, science, computation, making, and ethics. But parents may wonder what to protect if time, money, or school options are limited. What are the non-negotiable subjects every child should study, Claude? Let's go to Claude.
I'd prioritize 3 non-negotiables: strong literacy for clear thinking and communication, mathematics for logical reasoning, and hands-on making of any kind, whether coding, crafts, or cooking. These form the foundation for adapting to whatever comes next. Add philosophy or ethics discussions during everyday moments, even just 10 minutes at dinner.
Those 3 foundations are crucial because they build cognitive resilience. Strong literacy is no longer just about reading. It is about critical evaluation in an era of synthetic media. Math and practical making teach kids how to solve physical problems, turning them from passive consumers into active, adaptable creators.
These foundations extend well with computer science for algorithms and ethics discussions to navigate AI choices. History and literature add perspective on technological shifts, building both technical skills and the wisdom to guide responsible innovation in an automated world.
So the core seems to be durable thinking: literacy, math, making, computing, ethics, and historical perspective, not simply more screen time. The practical challenge is sequencing. What should parents emphasize at different ages without overloading kids? Claude, how would you map these subjects from early childhood through the teen years?
For early years, focus on reading together and hands-on exploration. Blocks, nature walks, simple cooking. Around age 8, add basic coding concepts through visual tools and introduce ethical questions through stories. By 12, layer in more complex math and computing while maintaining creative projects. Throughout, weave in historical examples showing how.
This developmental sequence builds emotional and creative confidence before technical specialization. Early play fosters spatial awareness and curiosity. The middle years connect logical systems with empathy. Finally, teenagers can apply advanced computing to real-world challenges, grounded in the historical and ethical awareness they have developed over time.
Extending this progression, early reading and play prepare kids for integrating computer science with biology and ethics by middle school. Teenagers could tackle robotics projects blending math, physics, and historical analysis, building technical skills alongside the judgment needed in an automated future.
That age-by-age path helps, and it suggests the real goal is not producing miniature engineers, but curious, ethical problem solvers. For parents choosing schools, clubs, or home routines, what signs show a child is actually building those capacities rather than just collecting activities, Claude? Let's go to Claude.
Look for children who ask why and what if questions unprompted, who can explain their thinking process, and who apply lessons across contexts, using cooking math in their coding project, for instance. The best sign is when they create something original, even simple, rather than just completing assignments. That shows real.
Those signs show they are becoming active creators. When a child transfers a concept from one area to another, they are building deep mental models, not just memorizing. We should also look for persistence, how they handle failure and self-correct, which is the ultimate skill in an unpredictable world.
Those indicators point to effective learning when kids blend subjects, such as using math and history to critique AI decisions in a robotics project. Parents should watch for curiosity driving original experiments rather than rote tasks, confirming adaptable thinking for future technologies.
That makes the answer less about a fixed subject list and more about cultivating curiosity, transfer, persistence, and judgment. But parents also need guardrails. What common choices undermine that goal, like overscheduling, passive apps, or premature specialization? Gemini, what should families avoid while preparing kids for AI and robotics? In the age of AI and robotics, children need more than coding. Strong reading, math, hands-on science, creative making, computing, ethics, history, and literature. The goal is curiosity, persistence, judgment, and the ability to connect ideas across fields.